So once you have finished copying the question, please give me a message. Okay. Okay then. So in this particular problem, what is that? The
So,
electric
sir,
motor.
1 minute, sir. 1 minute, sir. 1 minute.
Okay, take your time.
Okay, sir.
Okay, dear. So in this particular problem, so what is driving what? That has to be found out first. So what is driving what here? So electric motor is driving an exhaust fan. So clearly he is indicating that the driver is an electric motor and the driven is an exhaust fan. By which type of belt is being driven? It is driven by a flat belt drive that is clearly being mentioned over here. Okay. Next, the following data known, it is clearly segregated. Data has been segregated. So motor pulley. So there are basically two pulleys, isn't it? One is a motor one, and other one is the fan pulley. So two pulleys is connected by a flat belt drive. So diameter of this is capital D is equals to 400 mm. Okay. And the fan pulley diameter is how much? Fan pulley diameter is 1200 mm. Small d. Okay. So by looking at the parameters, you can judge that these two are unequal in size. So this is bigger in size. What you can do is you can just replace your diagram with a bigger diagram like this, something like this. Okay. So this is being given. And theta L. What is theta and theta L and theta S? Anyone? What is this theta L? It's been long back. I know that it's been 4 to 5 days before your internals we had solved this, but yet. So what do you mean by contact angle? Anyone who remembers it? What is that angle referred to? Anyone? Sudhanshu?
Yes, sir.
What is angle of contact? What is this theta S? What do you mean by theta S and what do you mean by theta L?
The angle between the two belts, which is connected to the gear.
Very good. So it is not called as a gear anymore. So gear in the sense it will be having a teeth on its surface. So this is what it is called. What is this particular element called? Huh? What it is called, Sudhanshu? Pulley. So it is P-U-L-L-E-Y. So it is known as the pulley. So the contact points are this point and this point, and the center of this particular pulley is this particular point. If I just join these lines and measure the angle between these two lines, this is what I called as angle of wrap of smaller pulley. So similarly, when I go for the bigger pulley again, it's the same thing. It's an angle of wrap. That means how much the belt has been wrapped over the circumference of a pulley. So that particular idea, this particular parameter will deficit clearly. Okay. Okay. So these is theta and theta. How much is the value? This. Hey, Tommy, what's the problem? You can give me a message in the chat box. I think there is some problem with your mic. Okay. Okay. So just write the values of theta S and theta L there. Okay. So theta S is how much? Theta S is 5 radians. Radians in the sense that it is half a circle. Theta L of a larger pulley is how much? 3.75 radians. Okay. Now, coefficient of friction is specified for both the pulleys. It is 0.3 for the larger one, for the smaller one, and mu s is equals to 0.25. Okay. Point for the larger, he says. The pulleys. Okay. Next, speed is 900 RPM. That is given the power transmitted is power transmitted is 25 kilowatts. Okay. Now, the thickness of the belt is given. So if I cut this section here, so whatever the section I would get is this particular section. So since this is a flat belt drive, the section would be a rectangular in shape. Okay. This would be a rectangular in shape. So the thickness of this particular belt is how much? Mentioned as 6 mm. It has been mentioned as 6 mm. Okay. Now, and the maximum permissible stress is how much? So sigma d, the maximum permissible stress is 2.1 megapascal. So this is the maximum permissible stress for this particular belt material. Density is being given. It is 1000 kg per meter cube. Okay. So what we are supposed to find here? So I think all the parameters are given. What we are supposed to find here? What we are supposed to find? Yes, what we are supposed to find here? Yes, we have to find the value of worth. Okay, we have to find the value of worth. Okay. So this is the problem. So the two decisions I have to make in this particular problem. Number one, should I consider the value of should I consider for the calculation of width of the belt? So that okay. So after that, decision number 2 is, should I consider the value of TC or should I neglect the value of TC? That is the one more decision which we need to make in this particular problem. If you make these two decisions in this problem, so you will get the accurate results. So the first question was, should I consider the smaller pulley or should I consider And the second question was particular problem. So I guess you have an answer. I guess you have a methodology by which you can decide upon, consider the value. Yes. So yes, we need to calculate the value of P. So all of you just calculate the value of P. So it is pi d n divided by 60. Okay, pi dn divided by 60. So should I consider thickness here? Since the value of thickness is given, so we need to consider the value of thickness over here. So it is pi into d plus t into n divided by 60. Please substitute all the values. It would be pi times of 0.4 plus 0.006 into 900 is the speed given divided by 60. So what is the value of velocity that you are going to get? What is the value? Okay, 19.13. Good. So Ruben, are you there? Ruben George? Ruben, okay. Girish? 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 Dhanush? Shetty? Dhanush? Switch on your mic, no? Switch on your mic, Dhanush.
Yes, sir.
So, yes, we have got the velocity that is as 19.13 meters per second. Now, should I consider the value of TC or should I neglect the value of TC? Yes, Amir is asking
Neglect.
neglect. Why we need to neglect Radvik?
It is 10.
Yes, so this value, whatever we have obtained, is greater than 10 meters per second. That's why you can just write a sentence, since the value of V is greater than 10 meters per second, neglecting, should we consider or should we neglect?
Neglect.
Who told you, Radvik? You confuse me also.
Consider correct.
So since the value of V is greater than 10 meters per second, so we need to consider the effect of centrifugal tension. So effect of centrifugal tension has to be considered there. Okay. Now, so considering centrifugal tension, so one decision we have made that you have to consider the centrifugal tension. That means we have to use that particular formula which states dTV by 1000 into sigma d minus omega v squared divided by 10 to the power of 6 into g into e to the power of mu theta minus 1 into e to the power of mu theta. So that particular formula, you have to use that. That is being cleared now. One more decision we need to make. What is that? That whether should I consider smaller pulley or whether should I consider the larger pulley. So how will you decide upon that is, please kindly note, since mu was different, okay? So mu was different, isn't it? So since, just write the sentence, since mu. How many of you remember on what basis, while we are explaining the gas or while we are dealing with the gas, we used to treat one part as a weaker part and we used to design the entire gear system based on the parameters of that particular gear, whether it might be a gear or it might be a pinion. So how many of you remember that condition? What is that condition on which you decide a weaker part? Yes? Based on the value of strength factor. Very good. So based on the value of strength factor, we'll decide whether it is into sigma d into that y. So based on that particular thing, we'll decide. Similarly here, since the value of mu is different, there the materials will be different. Here the value of mu is different. So mu is different for both pulley. So design is based on pulley. I could not able to write properly because I don't have a proper arrangement here. Please adjust. Okay. Whichever have based on the pulley having smaller value of mu theta or e to the power of mu theta. So if there are two pulleys for in case in this particular problem, so you need to calculate the value of mu theta or e to the power of mu theta. It's your choice, whichever you calculate, whether to calculate mu theta or whether to calculate e to the power of mu theta. You just calculate mu theta of both the things. Okay. Compare these two values and whichever is the smaller value, on that particular thing, you have to base your design. Simple. Similar to the strength factor there, isn't it? So now, all of you just calculate the value of mu theta for the smaller pulley and the mu theta for the larger pulley. So what is the value of mu theta? Compare these two. Yes. Okay. 0.75 and 0.93. Okay. 0.75 and 0.93. So out of which smaller value is smaller pulley, so we'll consider that particular thing. Okay. So motor pulley for motor pulley 0.3 into 0.25, so the value would be 0.75. And for the fan pulley, it is mu s into theta s, that is equal to 0.25 cross 3.75 is equals to 0.938. Now, so you need to consider the motor pulley because its value is smaller. So use that particular equation. P is equals to BTV divided by 1000 into sigma D minus omega V square divided by 10 to the power of 6 into G into e to the power of mu theta minus 1 divided by e to the power of mu theta. Okay. So from this, power is given as 25, substitute that. So B you need to calculate. 6 is the value of thickness. Velocity is 19.13 divided by 1000 into sigma D value is 2.1 minus omega is 1000 into 9.81. So directly I have done here, converted into weight density and directly have substituted it. And V again is 19.13 whole square divided by 10 to the power of 6 cross G value is again 9.81 into e to the power of, I can have directly calculated the value of mu into theta. So substituting the smaller value, it is 0.75 e to the power of 0.75 minus 1 divided by e to the power of 0.75. Okay, so the value of B from this huge equation, what is the value? So whatever you get, you would get it in M. Very good, very good, very good. Okay. So 238.048. Now, there is something called as a standard belt size. You cannot manufacture a belt which is having 238.048 mm of thickness, isn't it? Definitely there will be some standard size. Now, next task is open your data handbooks, all of you. Just check a table or a source through which I can standardize the value obtained. So B is 238 something. No, I need some standard value for this. It might be a whole number which is available in the market for the purchase. Okay, so I need some value of that order. So please check your data handbook. Very good, man. So how did you get the value of 250, Nitesh? How did you get it? What did you refer? So yes, so that particular information is being available in 14.9 A table number in page number 313. So in the page number 313, the table number 14.9a, you will get that information. So yes, you are right. So even the value of the textbook is same. The value of width is 250 mm. Okay, if you just solve this, you would get 10 marks. A simple one-line substitution problem directly. So the answer, if you get 250 mm, so you'll be getting 10 marks in your examination. Okay. Now, I was just thinking this is the only hour which I have in the afternoon. Okay, so shall I give you the questions now and solve it in the next class since it is an afternoon class? Is that okay? Okay, good. So now what you do is, all of you just take the screenshot of the problems, whatever I show. Just try it. It is not so difficult enough. Rather, it does not require any sort of explanation for you. It's already an easy thing. You can have that. Okay. So if you don't get it, I will solve it in the next class. Just take a screenshot of this particular problem. Done. Taken. One more problem is done. So once you have taken it, I will move it. Okay. So take even this. Take a screenshot of this. You can mark your attendance in the Google Sheet, which I have provided to you. So we'll meet up in the next class. Okay. So hopefully in the next class I will be giving you the marks, displaying you the marks of your first IA. So till then, have a great time ahead. Stay at home. Be safe. Take care.
Sir, Radvik.
Radvik, ಹಾಕ್ತಾನೆ
Sir Gagan.
ಒಂದು ನಿಮಿಷ ತಾಳ್ರ